The moment of inertia of a uniform thin rod of length L and mass m about an axis passing through a point at a distance of L by 3 from one of its end and perpendicular to rod is. So in this question we have to find out the moment of inertia. Okay, now one rod is given there. We know that if axis is passing through the center of mass, moment of inertia is ml square by 12. If axis is passing through one of its end, then moment of inertia ml square by 3. Okay, you should know this reading. Now in the question we have asked that the axis is passing through a distance of L by 3 from one of its end, means if I am considering this axis, so this distance is L by 3. This distance is L by 3. If this distance is L by 3, in the question it is given that the rod is of length L. So this distance will become, this axis is passing through, this axis is passing through center of mass. So this will become L by 2. So this length will become L by 2 minus L by 3, which is L by 6. Okay, so this length is L by 6. Now on this two particular axes, they are parallel to each other and this axis is passing through the center of mass. So we can use parallel axis theorem. What is parallel axis theorem? We can use here parallel axis theorem. Parallel axis theorem. So what is parallel axis theorem? Moment of inertia, जिसके about moment of inertia निकालना है, equals to ICM plus md square. Okay, so ICM is axis passing through center of mass, उसका moment of inertia क्या है? ml square by 12 plus m. D is what? Distance between the axis and axis which is passing through center of mass. Here it is L by 6 whole square. So therefore I will be equals to ml square by 12 plus ml square by 36. If you solve this, you will get ml square by 9. So option B is correct. Now in this question, we know the moment of inertia about this axis. So can we use parallel axis theorem about this axis and this axis? Okay? No. Why? Because none of these two axes is passing through the center of mass. Okay, so we can only use parallel axis theorem for this. In this case, we have considered this axis. Okay, but here if you take this axis, this is also one end. So if you take this distance L by 3, then also you will get the same moment of inertia, because again this will come L by 6 only. Okay, so here correct answer is option B, ml square by 9 is correct.